So all of you listen here. Good, happy New Year to everyone. Happy New Year, sir. Happy New Year. So what are the topics we are going to discuss in module 2? That is based on sensors and actuators. So these things we have already seen. So we'll be having introduction, sensors, sensor characteristics, deviations, then sensor types, conditions and actuators, and all these are the topics which are going to study in this module 2. Okay. So so what you can see here. So what is a sensor? What we have studied all these things in the previous class already. So what is a sensor you have understood of? These all topics we have been discussed. So I am going to ask you these things. So what is a sensor? What you understood? Okay. Which has the capability to sense the information. So it will be in the form of humidity, temperature, pressure, and what else? So there are many parameters which need to be measured in the physical world. So you need a sensor, isn't it? So do you have any sensors in your body? Yes, sir. Is there any sensor? How many sensors? Five sensors. Six sensors. Some of them are having six, some of them are having five. Okay. Thank God a lot of people who also similar. The five and six sensors. So, what is the sensor you have? The sense of smell, sense of taste, sound, and sound. So, how it is happening? You have a system, nervous system. So you need only sensor is there, it's not going to drive you. You need what? You need a system. So what you are going to do here also, you are going to measure sensor what it is going to see. If you have, for example, smell, they are going to feel it. But whether it is good smell, not good smell, or something good flavor, what it is, all those things to know, it has to reach your brain, isn't it? So that is what here also you will be measuring all these sensing things with the help of temperature or pressure, humidity, or whatever it is. But it has to go to the microcontrollers and then raspberry or whatever devices you are setting up. It has to make sure that whether it is high temperature, low temperature, what it is also this is very important. So that is where the application comes into picture. So you have light, sound, chemical, all these things has to be seen at various. So what are the things you have seen here in this slide? So these things were discussed in the last class. So what are the things different between transducer and sensor? So what is the main difference between transducer and sensor? Transducer is the function of sensor and actuator. Okay. So all these things were explained in the last class, right? Yes, sir. So okay, fine. So you can see here if there is a fire taking place in an industry. So how if you are, let us take an application, you take a room and you have made all the arrangements such that there is a lot of high temperature process is happening. For example, here in this room, you are manufacturing tractors and all. It's very important that you make sure that the temperature is maintained. There should not be any unnecessary fire coming into that process and all these things, isn't it? So, if you are having a entire any room, you have in the industry, you have an industry application where what all things are there. You have some industry where you have both heat being generated. You can say around 200, 300 degree, 400 degree temperature. But if it crosses above 500 degree, you may say that there is a chance of catching fire. Okay. So the industry operation keeps moving on, and somewhere around 400, 450 and on, there will be no alarm being raised. Right? Because the chance of fire is less. Once it crosses at least 500 degree, what will happen? What will happen? The sensor will measure that temperature. After measuring that temperature, it will understand that it is not above 500. So what it is going to do? It will be keep on passing that information to the computer, isn't it? So when it goes beyond a threshold level, what will happen? It will create an alarm system that there is a probability of fire getting means it's a chance of a fire to be established at this location. So you can go and make the temperature less, or if it is a feedback loop kind of mechanism, what it is going to do? It is going to pump water, or it is going to bring put some AC content, or somehow it is going to bring the temperature below to 500. So that is what the industrial application is going to take place. So there will be the power requirement, sensor output, and what are the properties to be measured. So this is how the temperature will be measured, and then it is passed on to the monitoring device. So continuously it will be monitored. Okay. So what else you have seen in the last class? What else you have seen? Have you discussed all these things in the previous class, right? Yeah. So what are the different types? You have analog and digital. So all these operations were discussed in the last class. Okay. Then let me see next one. Measured properties and all these things were done. Okay. So what is a vector? What do you mean by vector? Vector. What you understood? See, for example, now you have seen if somebody is getting sudden shock and all, what they are going to do? They are going to make them lie down, and they are going to connect all. What is that? ECG. They are not going to connect. They are going to connect ECG. Okay. Whether see that pulses will be very minute. So is that then you might have seen, no? You might have seen that one here, then the hands they will keep these all places they will keep almost around 10 to 15 they will keep. Okay. And they will measure the entire value. You can see that. Have you seen in that device in the monitor that the variations can be observed? You have seen. So in most of the films you can see that, right? So after to showcase that the person is dead, they remove that and make it as completely dead. Okay, that is what you might have observed in most of the movies that how this sensing takes place. They show the inside of ICU and all. They have shown you how the sensing device takes place and monitors the entire process. So these all things are very important. So so gyroscope, all these are examples for where you can measure the what the doctor will do first of all. He will keep track all those things and put it on your hands and just and see back and now check whether any sound is getting generated. So how he is going to get all these things, because it is going to get a small vibrations. Okay. So that vibrations can be made that vibrations are enough? No. Now that will be small signals. Now what you have to do, you need to see. For example, ECG is a signal. Okay. So that will be very small signal when you measure it. But when you do that, can you process it further? No. What you have to do, you need to, it will be addition of noise also will be there. You need to filter out the noise, right? Then you need to amplify the signal. Okay. Once you amplify the signal, then only you can show that whatever you see in the screen, like this, how you have seen the signal. Anyone of you know how the signal will be looking like? No, sir. Yeah, here it is there, no? So, you can see that somewhere the peaks will be there, and then further it will be. So every peak is very important. There are the tube peak, and all those rotations are there for measuring whether it is cardiac arrest has taken place or not. All those things are there. So that is all you are going to see that later. So this is the functional block of the typical sensor node in IoT. This is very important. So what you have understood here? This I want to know. How this is what you understood? Yeah, you can stand up and say louder. I'll give you this. Yeah, if they both, you don't have here. Okay, fine. We are going to see the block representation of a sensor node. So, what are the things? Listen here. Just to support you, you can just see here. What are the things has to be measured? For example, you need to measure the light, temperature, then position of the. For example, you might have seen how the see this robot is there, no? It will be having lot of sensors. For example, it to move its fingers, its hand, and eye movement, and the posture to walk. So all those things it needs the entire sensors and all those things. So let us see that after that he will show you how the robot walks. Okay.
According to the first, after sensing the changes in the environment or the temperature or anything like given on the
Anything like this given.
light speed, position, we receive analog signals which is then converted into digital electrical signals using converter, which then goes into the processor, which is processed, and then is another electrical signal is sent to the acceptor, which performs the actions. So if you take car parking,
You like car? You like car? So he is taking an example of car parking. Okay.
Whenever you as soon as you come and stop the car at the gate, it will give you a token, and as soon as you receive it, the sensors will activate and the gate will open, and you can move your car. That is one of the examples for it. And for functioning of the sensors, you need power. So the DC motor, or you can use an alternative.
And that's it. Wi-Fi, Bluetooth, and all is there. Okay. See, the power has to be connected to the processor. That's what we have shown. And you can also see that the connectivity. For example, now the information has to be passed on to somewhere else. So what are things you need? The module 1 we have studied how the transfer of information takes place with the help of Wi-Fi, Bluetooth, Zigbee, then all those can be used in order to transmit the information from one end to another. For example, the doctor is measuring all the parameters. The patient is reading all the parameters with the help of sensors in the hospital. But 24/7, the doctor cannot sit in the hospital. Even his relatives also will try to be at home. Okay, but make sure that with the help of all these devices, it will be continuously monitoring the whatever parameter the patient is kept for. For example, if his temperature and heart rate, pulse rate, all these things are being measured. So continuously it will be given to the doctor as well as the relative. So how it will be transmitted? Through the help of how it will be transmitted? Okay, fine. Yeah. You have so it's a nice initiative in the first semester in the new year. So having explanation on the that. Okay. So if you are all see whether you mean first day is a new year. So if anyone else is interested, this is will be more opportunities for you. So is that clear for you? Anything? Is that clear? It is not. So, so these are some of the sensors. So what are the different sensors you can see here? Camera sensor, then color sensor, then frame sensor, gas sensor. So, for example, some around 20-25 years back, we used to do some gas leakage and how to measure the gas leakage. So with the help of this sensor, you can see what the students used to do is this sensor is there. Sensor they will on and then off. Put it in front of this, it will give the alarm that gas is leaked. Okay. Because it will sense, you need to connect this sensor to the Arduino board and all those things. Next setup is there. As verified or whatever board you are using, that is fine. But you need to do the setup, and if you have this gas sensor with you, and as I have told, the vendor you just switch it off and keep it close to that, it will give an alarm saying that okay, gas is leaking. Real application where it is in your kitchen, you can device, you can do a thing, build a device. I have told you to make the project, right? So one of the batch can take this also as a project. Gas leaking or monitoring of a gas leakage. Okay. So this is how you can measure it and calculate. So what is the next one? Infrared sensor, rainfall sensor. All these are different type of sensors available in the market. Okay. What is sensor characteristics? What is sensor characteristics? This also was discussed in the last class. Sensor characteristics was discussed. So, what was sensor characteristics? Now I will connect two words. The apart from this, one one more topic is load for I will tell you this here. One more topic yeah, sensor characteristics.
Has to be accurate.
Accurate, why?
Because if the sensor is not accurate, the readings will be. No, sir.
Take care, no problem. It's something is doing good. Yeah.
Sensor, if the sensor is not accurate, the readings will be wrong. And if I
Sensor is
the sensor resolution, sensor accuracy.
yeah, sensor resolution, sensor accuracy, and sensor precision. Where this is very much important. Some cases it might not be that important, but some cases it is very important. Like military application, healthcare, it's very important. Like the temperature is 99 and the patient temperature is 103 and it is showing 99. So it will be the wrong assumption. Okay. Pulse rate, all these things has to be precise. There is no compromise in that. They say that whatever accuracy you do, there will be minute error. That is there. It is unavoidable. Okay. But to be very precise, we have to have a very precise sensors. So let us see. We are going to hear from him what are the things. What you want to explain? Resolution, accuracy, simplicity, accuracy. If you are not accurate, what will happen in cricket match? Correct, no? So in a sensor device, what will happen if accuracy is not correct?
The mechanism would not work in the right order.
Mechanism?
Would not work in the right
You
order.
know, that's why you are saying you don't know. Now, what will happen?
If the sensors are
In cricket match, what will happen if accuracy and precision? Accuracy and precision, if it is not correct, what will happen?
we will miss the balls and
You will miss the
we will miss
ball.
the timing.
Correct. In case of sensor, what will happen?
We will miss the working of the mechanism.
Yeah, it's in sensor. It is very important to have accuracy as well as precision. What will happen if you are, for example, you are in a place where war is taking place. Okay, and accuracy and precision is very important. Otherwise, the opponent is even fire and
We are from the previous committee HPC. Anything we have regarding department, college-wise, hostel improvements you need, any grievance can be open.
So all this sensor characteristics, sensor resolution. So what is resolution? The smallest change. See, that's what I am saying. It will be very small, minute change. The smallest change, whatever occurs within the surroundings, wherever the sensor is placed, you should be able to measure it. Okay. For example, if you say that the pulse, when it is connected to a patient, if there is no pulse or there is a random movement of pulse, all those things has to be measured. You know that it is very difficult to find the pulses, isn't it? So that small movement also you should be able to measure it. Okay. The smallest change is measurable quantity that the sensor can delve is referred to as resolution. Then this is example we have seen with respect to temperature, pulse, humidity, anything. That small change, whatever it comes, you have to measure it. What is accuracy? We told that if you are not accurate, you miss the board. When you are playing in cricket match, it predicts you also. Okay. Accuracy is what? The measure the system close and it has to be true. Means if it is accuracy means if you are measuring the temperature, if I told you if it is 99 degree Fahrenheit for a person, you should not show 103, and if it is 103, you should not show 99. It should be precise. If it is 103, you should show 103. If it is 99, you should show 99. So that is what is required. For example, now if you weight you measure, so suddenly in some places you can see that it has gone 10 kg or 5 kg more. So you think I have not taken food for almost a week, still my weight is the same. Okay. Usually for this side low, this side more it is. So that is why we don't see all this kind of things. We eat and we try to have more and more things. So that is what whatever measuring things are there, it has to be precise. So it can be, see, as I have told you, error will be there. It can be 0.01% of error. It is possible. We cannot completely eliminate the error. Some portion of the error will be there. So precision. What is precision? What is precision? Yeah. If I do multiple times also. Okay. So if I do multiple times also, it has to give me the same reading. Then it is called as precision. What you will do when you go and stand in front of a weighing machine? First, you do your first record at least one time. So that's it. Again, sometimes if you have one, you will do one. So that and everything will do it. And somehow make it less than 16 or 15, whatever it is. So, but 10 times also you stand in that specific time. You should be, machine should show the same reading. So that is what is very important. It should not be like one time it is 98, another time it is 100, then suddenly it goes to 96. So that variations should not be there. So these things are there. So what else you have seen? The next topic was sensorial. So what is deviation? What is sensorial deviation? This also you have discussed, isn't it? Deviation means what? Diversion. So sensorial deviation means what? The error. Whatever error it takes place in the process. Okay. So most of the sensing IoT is non-critical. Some of the places the deviations play a major role. For example, have you seen the not know when war takes place? They used to fire Richard. This will be there now. Aircraft will be flying. So they used to fire like this. But still they were not able to attack it. But different pattern they do it. Okay. So if there is a slight deviation also, they cannot attain that target. So it's very important to have 100% precision. Not even a single deviation is possible there. So that's why it is. We will be seeing here how the deviations can be eliminated. Okay. So what all things we have seen. So how to minimize the value of or maximize the values. All those things we have seen in the last class. This is taken, right? Once I will share you the PPT. Once you go through it, I will take the next topic. If you require, I will take this topic. If you require, I think once you read it, you will understand. If you are not able to understand, I will take it. So we'll. I think these things were discussed in the last class. We'll stop it for today. Then. What is the next topic to be discussed now? Sensing types. So we will be discussing sensing types in the next class. So sensing types, including sensing types, will be there for your internals. Okay, let's thank you.